Welcome, geometry students, to another Regents review video. This is the January 2016 Geometry Common Core Regents exam, and these are the answers. These are the solutions to parts 2 through 4 of the January 2016 Regents exam in geometry. Just a warning beforehand that this video is unfortunately going to be very long because the part 2's 3s and 4s, the open-ended response questions in geometry, are really in-depth, so they will take a while to explain. If you are here to copy my answers, please refrain from doing so and get off of my webpage, because these questions are here for you to check your answers and to help you if you really need guidance. So if you are here to do that, welcome, and I hope that this will help you. So without further ado, let's just jump right into the part 2s, 3s, and 4s of the January 2016 Geometry Regents exam. Here we go. So question 25 says that triangle ABC is graphed on the set of axes below. Graph and label triangle A prime, B prime, C prime, the image of triangle ABC after a reflection over the line x is equal to 1. One of the problems that I see with geometry students is that they are unable to graph vertical lines. The line x equals 1 is a vertical line passing through all values of x is equal to 1. Okay, so if I were to just graph the line for you, x is equal to positive 1, it would look something like this. That's the line x is equal to 1. Okay, so if I were to just reflect over that line, I would get this over here. I would get b prime over here, I would get c prime over here, and a prime over here. Make sure that you label it correctly too, because they do take off for labeling because they specifically said label. So here is my triangle, and that's simple. That's question number 25. Moving on to 26. In the diagram below of circle O with diameter BC and radius OA, chord DC is parallel to chord BA. Okay. Chord CD is parallel to chord BA. Parallel chords intercept congruent arcs. That's a theorem that you need to know when you're dealing with circles. The theorem states that parallel chords intercept congruent arcs. Now let's read a little bit more into it. It says that if the measure of angle BCD, so this angle over here is 30, what is the measure of angle AOB? So we're looking for this over here, that angle right there. Okay? Now, it's actually not that bad of a question. This 30-degree measure is an inscribed angle, and an inscribed angle is 1/2 of the arc it intercepts. So if this is 30, arc BD is going to be 60 degrees. Now, I just said before that parallel chords intercept congruent arcs. So if this is 60, arc AC is also 60 degrees. But what does that tell us? Well, it tells us what this angle is over here. That red angle is a central angle, and a central angle is equal to the arc it intercepts. See how this angle touches arc AC? So this angle over here is actually 60 degrees. Great. But what else does that tell us? Well, this line right over here is a linear pair, and linear pairs are supplementary. So this is going to be 180 degrees minus 60 degrees, and that is going to give us an angle measure of 120, which is the final outcome. So the measure of angle AOB is equal to 120 degrees. So as you can see, that's why geometry is so difficult, because there's so many concepts in one question. There were what, 1, 2, 3, I think there were what, 4 or 3 concepts in this one question. It's a lot of work. So please make sure that you know your stuff. Okay, number 27. Again, this question, teachers teach it differently. I teach it very differently. Directed line segment PT has endpoints whose coordinates are -2, 1 and 4, 7. Determine the coordinates of point J that divides a segment into a 2-to-1 ratio. So what I like to do is I like to do it algebraically. Okay, I'm going to show you both ways. I'm going to do it algebraically, and then I'm going to show you graphically, because there was a graph on this question. So here's my x value, and here's my y value. Here are the equations to get these results. X minus x1 over x2 minus x is equal to the given ratio. And we have y minus y1 over y2 minus y is equal to the, sorry, that should be up here. Whoops. Is equal to the given ratio. Okay? So the given ratio is in a ratio of 2 to 1. And we have the points -2, 1, and 4, 7. Well, point P is x1, y1. Point T is x2, y2. Great. Well, we know that information. So now what's going to happen here is we are just going to plug in this information. I'm going to get rid of this graph for a second. Put it up here. Okay. So we get x minus -2 over 4 minus x is equal to the given ratio of 2 over 1. So now from here we are going to cross multiply. So we get x plus 2 is equal to 2 times 4 minus x. Distribute that 2, we get x plus 2 is equal to 8 minus 2x. We are going to subtract the x on both sides. And I'm going to, I'm also going to subtract the 8. Just to save some time. So we get -6 is equal to -3x. Divide by -3 on both sides. You get x is equal to +2. Okay, great. So now we're going to do it to the y value. The y value is y minus 1 over 7 minus y is equal to the given ratio of 2 over 1. Once again, it's the same process. We're just going to cross multiply. So we get y minus 1 is equal to 2 times 7 minus y. Distribute that 2. We get y minus 1 is equal to 14 minus 2y. I'm going to add that 2y on both sides. I then get 3y is equal to, I'm going to add that 1 as well. I get 15. And then last but not least, we divide by that 3, and we get y is equal to 5. Now, in order to get full credit, it says determine the coordinates. So that means you actually need to write the coordinate. J is 2, 5. Okay? So that's how you do it algebraically. I am now going to show you how to do it graphically. So I'm going to expand this graph page, and I'm going to move it up front. There we go. Okay, so I'm going to graph the points that they gave us. I'm going to graph the point -2, 1. So this right here, this is point P. And 4, 7 is up here, which is point T. Okay, so now it says determine and state the coordinates of point J. So we need to figure out the slope of line PT. We go up 1, 2, 3, 4, 5, 6 over 1, 2, 3, 4, 5, 6. That's great. The slope is 1 over 1. So what I'm going to do is I'm just going to go up 1 over 1 each time. I'm then going to draw my line. Now, it specifically said a 2 to 1 ratio. So if there are 1, 2, 3, 4, 5, there are 6 segments in the, there are 6 little segments in the big segment. Well, how do we split up 6 into a ratio of 2 to 1? Well, why don't we try 4 to 2? 4 segments to 2 segments is in a ratio of 2 to 1. So where it touches, where they intersect, which is actually right here, that point is the point J, which is the point, look here, 2, 1, 2, 3, 4, 5. So that's 2, 5, and it is the exact same result. And that's how you do it on a graph page. All right, moving on to question number 28. As graphed on the set of axes below, triangle A prime B prime C prime is the image of triangle ABC after a sequence of transformations. Is triangle A prime B prime C prime congruent to triangle ABC? Use the properties of rigid motions to explain your answer. Well, this is showing a reflection followed by a translation. And both of those transformations are rigid motions. So we're going to say yes, because I'm going to make this bigger, because a reflection and a translation are rigid motions, which preserves distance and congruency. Now we give you full credit. All right. Now, I said this in a couple videos in the past, and I want to say it one more time on this video. You have to say distance and congruency. If you watch my previous videos, I said that if you say size and shape, you get it marked wrong, because I believe that the state education department wants you to use distance and congruency. That doesn't mean that your answer is wrong. And if your teacher said, yeah, use size and shape, don't go criticize him or her, because I don't know how they grade. But the state of New York wants you to use mathematical vocabulary, so they want you to use the words distance and congruency as opposed to shape and size, because we are big boys and girls, so they want us to use big boys and girls words. So that's why I always say distance and congruency. It's kind of just one of those things that you have to memorize as well. Number 29. A carpenter leans an extension ladder against a house to reach the bottom of a window 30 feet above the ground. As shown in the diagram below, the ladder makes a 70-degree angle with the ground. To the nearest foot, determine and state the length of the ladder. Okay, that's your x. So we are going to be using SOHCAHTOA. Your 70 is your reference angle, so I'm going to draw my little guy over there. Now, in order to figure this out, we need to figure out, well, what is this and what is this? The hypotenuse is always across from your right angle. So this x value is actually your hypotenuse. This 30 over here is your opposite side because it is across from your reference angle. So if we have the opposite and the hypotenuse, we are going to be using sine. So let's go ahead and solve this. So we have the sine of some angle, theta, is equal to the opposite over the hypotenuse. That's the standard form that we're in. So the sine of 70 degrees is equal to the opposite, which is 30, over the hypotenuse, which is x. Now we just cross multiply. X sine of 70 is equal to 30, and now I'm going to divide by the sine of 70 on both sides. So we get x is approximately equal to, what do we have here? Make sure that your calculator's in degree mode. I use a TI Inspire, by the way. I'm going to go up to my trig button, go to sine, and then, no, I'm sorry, I'm going to type in a fraction. Control division, 30 over the sine of 70. And that is approximately 31.9, which they say round it to the nearest foot. So that's approximately 32 feet in order to get that question right. And that is question number 29. Moving on to question 30. This one was interesting. During an experiment, the same type of bacteria is grown in two petri dishes. Petri dish A has a diameter of 51 millimeters and has approximately 40,000 bacteria after 1 hour. Petri dish B has a diameter of 75 millimeters and has approximately 72,000 bacteria after 1 hour. Determine and state which petri dish has the greater population density of bacteria at the end of the first hour. You need to know what population density is. So the population density formula is equal to the population over the area. What this does is it takes the entire population and divides it by how much space there is. So that will tell us which one has the greater one. So let's take a look at Petri dish A. Okay, so Petri dish A the population density of this Petri dish is equal to 40,000 because there are 40,000 bacteria after 1 hour divided by, now, the area of what? The area of a circle. So the area, remember that the area of a circle is pi r squared. Okay? So it's pi times the radius. Now they tell us what the diameter is. It's 51. So your radius is 51 divided by 2. And then you square it. And when you type that into your calculator, let's see what we get. Control division 40,000 divided by pi times 51 halves squared. That's equal to 19.58. So that's approximately 19.6. Approximately 19.6 for the population density. Now we have to figure out, well, what is Petri dish B? So let's do that right now. Petri dish B. There's a lot of work for part 2, that's for sure. So the population density of this one is equal to 72,000 now, divided by pi. Now they tell us what the diameter is. The diameter is 75 millimeters. So it's 75 over 2 because we want the radius, and then you square it. So now I'm going to type that into my calculator, control division. 72,000 over pi times the radius of 75 halves squared. And we get 16.3-ish. That's approximately 16.3. So it says here, determine and state which Petri dish has the greater population density after the first hour. That is going to be Petri dish A is your answer. So it is going to be this dish right there has the greater population density. That was definitely an interesting question. Okay, number 31. Line L is mapped onto line M by a dilation centered at the origin with a scale factor of 2. The equation of line L is 3x minus y equals 4. Determine and state an equation for line M. So here we have 3x minus y is equal to 4. Real quick, I just want to put this in y equals mx plus b form first. Okay? So I'm going to subtract the 3x on both sides. I get negative y is equal to negative 3x plus 4. And then I'm going to divide by the negative 1 by each. So I get y is equal to positive 3x minus 4. Now, it says it's being dilated. When you dilate a line, okay, because it is now being dilated by a scale factor of 2. So we're going to dilate this line by a scale factor of 2, but we need to talk about this for a second. What are we doing? Well, a dilation by a scale factor of 2. And when are we dilating? Well, when dilating a line, the slope, which is your m value, the slope remains the same, and the y-intercept, which is where the line crosses the x-axis, the y-intercept is multiplied by the scale factor. That's important here. So the slope does not change. That 3 has to remain the same. That negative 4 is going to change. We're going to multiply the negative 4 by 2. So your new line is y is equal to 3x minus 4 times 2, which is 8. Ladies and gentlemen, that is your equation of the new line. Y is equal to 3x minus 8. And that is the end of the part 2s. Now we're going on to the part 3s. Part 3s are definitely more in-depth. So here we go. The aspect ratio, which is the ratio of screen width to height of a rectangular flat screen television, is 16:9. The height of the diagonal of the screen of the television size. No, I'm sorry. I read that weird. The length of the diagonal of the screen is the television screen size. That's better. Determine and state to the nearest inch the screen size, which is the diagonal of this flat screen television with a screen height of 20.6. So, first things first, I want to draw a TV. So, draw me a TV. And we're going to put a diagonal because it's talking about the aspect ratio. Or the length of the diagonal is the length of the screen. So, the aspect ratio of this is 16:9. That means that this is 16x and this is 9x. Whenever it says ratio, you put an x after the numbers. Always put an x after the numbers because it's considered an unknown. Now, we're trying to solve for this. I'm going to call this over here, I'm going to call that y because we already have x's here. Now, what do we do now? We don't have any x values, or we don't have the value of x. You need to solve it. And where do you get that information from? You get it right here. They tell you that the screen height is 20.6. That information is vital to get this question right. Because we need to take 20.6 inches and set it equal to the height, which is 9x, to solve for x. So we're going to divide by 9 on both sides. Then you get x is approximately equal to 2.28 repeating. The 8 is repeating. Now, we have the value of x. What is this? What is that right here? Well, that, my friend, is a right triangle. And a right triangle is special because we could apply the Pythagorean theorem to solve for the length of the diagonal, or the screen length. So what I'm going to do right now is I'm going to use the formula a squared plus b squared is equal to c squared. So we need to really take our time with this. Your a squared is 16x, but we already know our x value. It's 2.28, repeating. So what I like to do is I like to do brackets. So we have 16 times 2.28 repeating, and square that whole thing, plus 9 times 2.28 repeating, and you square that whole thing, and you get that to be equal to y squared. Great. We now need to type this into our calculator, because the calculator has to do all the work. So it's 16 times 2.288888, repeat. Now, I usually put in 1, 2, 3. I put in 5/8. That's fine. You don't need to put in the whole thing. Plus 9 times 2.2, 1, 2, 3, 4, 5/8, and then square it, and you get that number right there. Now you have to take the square root of that number. So it's 1765.54716049 is equal to c squared, and now you take the square root of both sides. So the square root of that number over there is equal to 42, approximately 42. So c is approximately equal to 42, and this, ladies and gentlemen, is your screen size, and that's why it is going to be that number. All right, that's how you do question number 32. Moving on to 33. Oh, goodness, I hate this proof. It's so stupid, for lack of better terms. It says, given the theorem, the sum of the measures of the interior angles of a triangle is 180 degrees. Complete the proof for this theorem. So it says, given that triangle ABC, prove that the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 is equal to 180 degrees. And it says, fill in the missing reasons below. Now, if you looked on various websites or maybe any other answer explanation video, the one thing that you see for number 2 is Euclid's parallel postulate. Okay? Now, Euclid's parallel postulate, I want to actually explain what that is. Okay? So, how am I going to do this? I think I'll just tell you you know what? I'm actually going to write it down. Okay, so let me just go back for a second and talk about this. So the first thing that says triangle ABC is given. It says, number 2, it says, through point C, draw line DCE parallel to AB. So there's some parallel lines going on here, but it's Euclid's parallel postulate. But what does that even mean? Well, here you go. So this is only for your info. This is the parallel postulate, or this is Euclid's parallel postulate. And it states, given any, you know what? I'm going to type this because I cannot write all this. Okay, so I am going to type this out using my keyboard, and you'll hear little clicky noises. So if you want to turn down your earphones, if you're listening on earphones, I would suggest that you do that now. Okay, so given any, I'm going to move over here. Given any straight line and a point not on it, there exists one and only one straight line which passes through that point and never intersects the first line, no matter how far they extend. Okay, so the parallel postulate states that right over here. Okay, so once again, let me read that again for you. It says here, given any straight line. So given any straight line, and a point is not on it, as in when they say there's a point not on it, they're talking about C and then AB. So C is not on line AB. So that's what they're talking about here. There exists one and only one straight line that passes through that point and never intersects the first line no matter how far they extend. So this line DCE is parallel to AB because it passes through point C, and no matter how far they extend, that they are always parallel. So that is the parallel postulate. I suggest right now that you pause the video and you write this down, but that should be the reason. But to shorten it, we just say Euclid's parallel postulate. Okay? Number 3. The measure of angle 1 is equal to the measure of angle ACD, and the measure of angle 3 is equal to the measure of angle BCD. Well, that is here. So the measure of angle 1 is congruent to ACD. That's over here. And angle 3 is congruent to BCE. So that's over here. So those are alternate interior angles. So we're going to say for a reason, alternate interior angles formed by parallel lines and a transversal are congruent. Okay? Then number 4, it says the measure of angle ACD plus angle 2 plus angle BCE is equal to 180 degrees. That is angles that form a straight line or a line are supplementary. All right. And last but not least, why are all of these angles add up to 180 degrees? That is by the substitution postulate. Now, let me explain what that means. So it says here that this angle over here, these angles add up to 180 degrees over here. Now, it says here that these angles in here, angle 1 plus angle 2 plus angle 3, is 180, and the reason why is this. If you take a straight line, which is up here, and these angles here, well, this angle over here, which is the alternate, let me get an eraser here. Angle 2 is all by its lonesome self. This angle over here is congruent to this angle over here, okay? These are congruent because those are alternate interior angles. This angle is congruent to this angle because those are alternate interior angles. If I prove that this is a linear pair, sorry, not a linear pair, this is a straight line formed by 3 angles, okay? And if all these angles form 180 degrees, and the blue angles are congruent and the red angles are congruent, the blue and the red plus angle 2 has to be 180 degrees. I hope that makes sense to you. That's by the substitution postulate. All right, and that's how you do that ridiculous proof. All right, moving on to question 34. Okay, before I begin this construction, understand right after I do this construction, there is an actual hands-on construction with me actually using my hands and not using my computer. So if you want to skip to that, by all means you can, or if you want to watch both, by all means. Triangle XYZ is shown below. Using a compass and straight edge on the line below, construct and label triangle ABC such that triangle ABC is congruent to triangle XYZ. Leave all construction marks. And then it says, based on your construction, state the theorem that justifies why triangle ABC is congruent to triangle XYZ. So we need to know the 5 ways to prove triangles congruent in the first place. The 5 ways to prove triangles congruent is side, 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 angle, side, angle, side, angle, 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 side, and last but not least, hypotenuse leg. Unfortunately for this question, we cannot use hypotenuse leg because it says nowhere in the instructions that this is a right angle or that this is a right triangle. So you could use any one of these to construct this triangle. For this video, I'm going to use side, angle, side. And by the way, I do the same thing for the next one. Well, in the more hands-on section. Okay, so those are the 5 ways to prove triangles congruent. What I'm going to do is I'm going to take my compass and do I need a straight edge? Yes, I do. I need a straight edge too. So the first thing that I want to do is I want to draw or plot point A. A is corresponding to x in this case. So what I'm going to do is I'm going to copy line segment XY. I'm going to extend all the way. What I'm doing right now is I'm drawing what I call a tick mark. A tick mark just shows the reader, hey, I measured this side. So I'm going to then copy it down below. And then I get that tick mark over here. And this tick mark over here, I'm going to call that point B. So right now we just got our first side. Excellent. Now I need to construct the angle. I need to copy that angle. So in order to do that, you place your compass point on X, you pick a decently sized arc, and you swing it around, just like that. Now, you repeat the process at point A, and you swing it around again, okay? So now we're almost done. We almost copied it, but now what we have to do is we have to place our compass point on the point of intersection on the bottom and actually measure the angle using the arm of the compass. So we do need to change this, and this right there is my other tick mark that represents the actual angle measure. So that's where I'm going to copy it down below. And as you can see, those are your two intersection points. Now the last piece that I need is I need side ZX. So that again is to copy a line segment. You extend your compass arm all the way to point Z, and you copy it, and you draw a tick mark. So then you place it down on point A, and you draw an arc in random space. That's perfectly fine, and it's normal. So now what I'm going to do is I'm going to take my straight edge. Actually, no, I'm not even going to use my straight edge. You have to use your straight edge. I have some straight line tools on my computer. I am then going to say, all right, well, I now have to connect all these points like this. I'm going to take point A, passing through the intersection point of the angle, and touch right up here. And it has to pass through that intersection point. Then I'm just going to take this point up here and draw it all the way down to point B. And look at that. These two triangles are congruent, and you have to specifically state the theorem. And I said the side angle side triangle congruency criterion or theorem. All right, and that is how you do that construction, and that's on the computer. The next part of this video is to construct with a more hands-on approach. All right, so this is question 34 from the January 2016 Regents exam. This is a hands-on example for the construction for those who do not like the computer software that I use. So the question says, triangle XYZ is shown below. Using a compass and straight edge on the line below, construct and label triangle ABC such that triangle ABC is congruent to triangle XYZ, and leave all construction marks. So the first thing that we have to understand is, what are we doing here? We're trying to copy this triangle from here to here. Now remember that these two triangles have to be congruent. Now there are 5 ways to prove triangles congruent, and here are the 5 ways to prove triangles congruent. We have side, 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 angle, side, angle, side, angle, 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 side, and hypotenuse leg. Those are the 5 ways to prove triangles congruent. Now, unfortunately, we can't be using hypotenuse leg in this case because it never says that triangle XYZ is a right triangle, so we cannot assume that. Now, for this construction, I am going to be constructing this triangle down here by side, angle, side congruency. So we need to take this and copy it down on this working line. So in order to do that, I need to place a point on this working line, and I'm going to call it point A. Now remember, labeling is key. A is corresponding to X because this is triangle ABC, XYZ. So point A is the same as point X. So the first thing that I'm going to do is I'm going to copy a side length. I'm going to copy XY first because this has to be the same as line AB. So I'm going to place my compass point on X, and I'm going to extend to the length of line segment XY. And what I do is I create what I call personally, I call it a tick mark. And that just shows the reader that, hey, I measured the length of line segment XY. Without changing your compass setting, I then repeat the process down below, place my compass point on A, and redrawing that tick mark. And this tick mark that you see over here, this point is the point B. Okay? So that's my first side. Now I have to copy an angle. Well, I'm going to copy angle X because that's probably the easiest way to do it. So what I do is I take my compass point, I place it on X, and I pick a reasonable arc length of my choice. What I then do is I swing my compass all the way around angle X, and it has to touch the triangle at 2 points, or 2 points of intersection. Without changing your compass setting, I then repeat the process on the working line below, and I just redraw that arc. Now make sure that the arc goes really far past what you intend it to be, meaning that this should be a little bit longer than the one that you have up here just to ensure accuracy. Now, we actually need to measure this angle. So I'm going to place my compass point on the bottom intersection point of the triangle, and I'm going to measure the length of that angle. And then I construct my tick mark, and I repeat the process down on the working line below. And that's perfect. Everything's perfect because everything intersects. Now, we're not done. We have to construct one more side. So what I'm going to do is I'm going to place my compass point on X, and I'm going to measure the length of XZ. So I extend my compass all the way to point Z, and I'm going to draw a tick mark, and I just measured that. So then you just repeat the process down below. You place your compass point on point A and draw an arc in open space. And that's okay if it's an open space. What I then do is I take my straight edge and I then take point B. Point A, and I pass through the intersection point of the angle that I constructed. Go all the way out until you touch that arc. So what I just did is I created a point up here. I'm going to call that point C. We're almost done. I'm then going to take point C and then connect it to point B. And those two triangles are now congruent. And then the question up here says, based on your construction, state the theorem that justifies why triangle ABC is congruent to triangle XYZ. Your answer would be side angle side congruency theorem. All right, and that is how you complete that construction. If you did this by side, angle, or angle, angle, side, those would be acceptable answers as well. And that is how you do that construction. Okay, here's question number 35. We're now on to the part 4s. The part 4s are really in-depth. So, let's take a look at 35. And this is going to take a while to do. Both of these, actually. Given parallelogram ANDR, with AW and DE bisecting NWD and REA at points W and E respectively, prove that triangle ANW is congruent to triangle DRE. Okay. I always like to make up a plan. The plan to prove these two triangles congruent is by side angle side, and I'll tell you why. This is a parallelogram. In a parallelogram, opposite sides are congruent, opposite angles are congruent, and since they said that E and W are bisectors, RE is congruent to EA, and WN is congruent to DW, and WN is congruent to RE. And I'll explain why that is in the proof, but that's by side angle side. Then we're going to prove that this is that AWDE, so the middle blank white section, we're going to prove why that's a parallelogram. So without further ado, let's jump right into it. All right, number 1. I'm going to list all my givens. All right, so here we go. Parallelogram. I'm just looking down at my notes here so I don't make a mistake with the lettering. A and D are. So that is given. Now, I personally sometimes like to separate my givens. I like to separate this given because we're talking about bisecting now. So I say that AW and DE are bisecting NWD and REA at points W and E respectively. And that is given to you. Now, what does a bisector prove? Okay, well, we're going to say that E is the midpoint of RA. And we are going to say that W is the midpoint of ND. And that reason is a bisector is drawn to its midpoint. Now, you don't have to state that E is a midpoint. I do. You could say that it is a bisector and just definition of bisector. So E is the midpoint of RA and W is the midpoint of DN. Okay? Now let's continue on. Number 4. Now, since we said it's a midpoint, we have to state that these segments are congruent to each other. So I'm going to say that RE is congruent to EA, and I'm going to say that NW is congruent to WD. And your reason is a midpoint divides a segment into two congruent parts. Great. Now, number 5, I'm going to say, well, okay, we just proved all that. Now I'm going to say that RA is congruent to ND. Now, the reason why I'm saying this is we first have to state that the opposite sides of a parallelogram are congruent in order to state that RE is congruent to WN. And you'll see why in just a moment here. But RA is congruent to ND because in a parallelogram, the opposite sides are congruent. Okay, so that is step 5. Now, step 6, I'm actually going to star step 6. I'm going to start in a different color here, and you'll see why. All right, I just started step 6. So step 6, I'm going to say that RE is congruent to NW. So if you go back up here, RE is now congruent to NW. You had to state first that the two sides were parallel and congruent, and then prove that RE is parallel to NW. And in addition to that, I'm going to say that EA is congruent to WD. And that's why I started this thing. EA and WD, EA over here and WD are not even included in this. So we're actually going to use this later. And you'll see why in about 3 minutes or so. Now, number 6 is the transitive postulate. Remember the transitive postulate? The transitive postulate is when A is equal to B and B is equal to C, then A is equal to C. So let me just get rid of all this stuff here for a moment. Let me just redraw that in. These triangles are congruent. So if RA is congruent to ND, and E is the midpoint, so therefore RE is congruent to EA and NW is congruent to WD. If RA is congruent to ND, and E is the midpoint of both, and E is the midpoint of this, and W is the midpoint of this, that means that E and W produce segments that are the exact same length. So therefore, RE could be proven congruent to NW by the transitive postulate. Number 7, I'm going to say that angle R is congruent to angle N, and that is up here because in a parallelogram, opposite angles are congruent. There's a lot of stuff. In a parallelogram, opposite angles are congruent. Number 8, I am then going to say that RD is congruent to AN, and I'm going to say, I'm going to say that in a parallelogram, the opposite sides are congruent. Now, why am I saying that now? Well, RD must be congruent to AN because that is your additional side. Remember, we're proving this by side angle side. We just proved one side by using the transitive postulate. We just proved the angle by the property of a parallelogram, and now we just proved our other side. So now we're done with that particular section of the proof. So number 9, I'm going to say that triangle ANW is congruent to triangle DRE, and your reason is side angle side is congruent to side angle side. All right, we are almost done. Now, what I like to do is I like to draw a nice squiggly line just to show that we're done with that section of the proof. Now we're going on to this. Prove that the quadrilateral AWDE is a parallelogram. Now, remember how I said I starred one of those statements up here? It was this one. We're going to use it right now. So, I'm going to say number 10. ED is congruent to AW. But we need to say that ED is congruent to AW because what that does for us is it says, hey, that is, those two sides are congruent and the opposite sides of a parallelogram are congruent. So therefore, we could prove this by CPCTC because we just proved these two blue triangles to be congruent. We could prove everything else in the triangles to be congruent as well, as long as they're corresponding. And last but not least, number 11, I'm going to bring that star back. We're going to use that star here. We say that quadrilateral AWDE is a parallelogram. Number 11, we say that two pairs of opposite sides that are congruent proves a parallelogram. So, two pairs of opposite sides that are congruent, that proves a parallelogram. And that, ladies and gentlemen, is your entire proof. If you lost me, now you probably can't even see that on your computer screen. But if you need to go back at all, please do so and just take it slowly and just rewind. The very last question on this Regents was a killer. Number 36 says, Kathy wants to determine the height of the flagpole, shown in the diagram below. She uses a survey instrument to measure the angle of elevation to the top of the flagpole and determines it to be 34.9 degrees. She then walks 8 meters closer and determines the new measure of angle of elevation is 52.8 degrees. At each measurement, the survey instrument is 1.7 meters above the ground. Determine and state to the nearest tenth of a meter the height of the flagpole. I'm going to call this big H for the height. Now, we need to think really, really hard about what we're doing. This here, this triangle here is a right triangle because a flagpole is perpendicular to the floor. And this big triangle is also a right triangle because, again, the flagpole is perpendicular to the floor. Now, why am I telling you this? And first of all, why am I not highlighting down here? Why is this all of a sudden gone? Because that's not a triangle. The triangles start at this point. They start over here because that's the measurement instrument. So it has to start up here. Now, I'm going to call this point or this side over here of the pink triangle, I'm going to call that X. And the whole green that you see here, I'm going to call this X plus 8. So all you see is just a whole bunch of unknowns. Okay. Now remember how I said in previous videos, and maybe this one I said too, if you have two triangles that are overlapping each other, it's a double tangency question. This is a double tangency question. So I'm going to say that the tangent of 52.8 degrees, that's the pink triangle. So the tangent of 52.8 degrees is equal to the opposite side, I'm going to use a different color, opposite side over the adjacent side. So that's big H over little x, okay? Now for the green triangle, I'm going to say that the tangent of 34.9, that's equal to the opposite, which is again h, over the adjacent, which is equal to x plus 8. Now what I'm going to do is I'm going to cross multiply these. So you get x tangent of 52.8 is equal to big H. And you have x plus 8 times the tangent of 34.9 is equal to big H. Wait a minute. What is this? Equals H? Equals H? These two equations are equal to each other. That's it. That is what we needed, because we can't work with two unknowns. We have to have some sort of one variable in the equation. We can't have two of them. So therefore it equals H. So that's great. We could set these two equations equal to each other. And let's do that right now. So we have x tangent of 52.8 is equal to x plus 8 times the tangent of 34.9. We now need to distribute tan of 34.9 to the x and the 8. So now we get x tangent of 52.8 is equal to x tangent of 34.9 plus 8 tangent of 34.9. One of the most common mistakes is a student takes 8 and multiplies it by 34.9. Do not do that. No. That is you're breaking the rules of algebra. So don't do that. Now, I'm going to subtract x tangent of 34.9. Subtract x tangent of 34.9. Why am I doing this? Well, I gotta pull out that x. That's a GCF. Now it's a GCF because I have x tangent of 52.8 minus x tangent of 34.9 is equal to 8 tangent of 34.9. That's great. So now I can take out an x. Take out an x, you're left with tangent of 52.8 minus the tangent of 34.9, and you get 8 tangent of 34. Now, we divide all of this by the tangent of 52.8 minus the tangent of 34.9. That is a whole hunk of numbers. These now cancel. Now, when you type this into your calculator, I will do it right now. Control division, 8 tangent of 34.9 over the tangent of 52.8 minus the tangent of 34.9. And you get, my apologies, that is not the right number because I forgot to separate this. There we go. That is equal to 9.003. So x is approximately equal to 9. Okay, that will help us. Now, remember what we're trying to find. And, it could get confusing at times. We're trying to find the height of the flagpole. That's great. X is approximately 9. Perfect. If you go back to the top, x is now 9. Wait a minute. Let me get rid of all this stuff. I just said to you that this is h and this is x is equal to 9. Isn't this a little triangle right here? And we could use very basic trigonometry to get this piece over here. I'm trying to get this right there, that height. But I'm not going to call it big H because I'll show you right now. I need an eraser. Big H is all of this. I'm going to call that y. So we have the tangent of 52.8 is equal to the opposite, which is y, over the adjacent, which is now 9. Cross multiply. You get 9 tangent of 52.8 is equal to y. And now when you type this into your calculator, you get 9 tangent of 52.8. Then you get 11.875. So that's y is equal to 11.875. And people stopped there and said, yeah, that's the height of the flagpole. No, it's not. Because what did we forget to do? That 1.7. we need to add that 1.7 to the y value. So it's really 11.875 plus 1.7. So your big H, so your final answer, is equal to 13.6 meters high. Star it, love it, and that is how you do that monstrosity of a question. Okay, that is the end of this video. I hope that it helped. Visit my website at www.nysmathreadersprep.com to get more math material and just to help you in all your math subjects in future years. And now there's a lot more geometry stuff on there as well. And make sure that you hit that subscribe button down below, and I would really appreciate it. And I hope to see you all soon.